Hello, I welcome you all in this presentation related to the subject fundamentals of the manufacturing processes, and we are talking about the methods used for improving the surface properties. So, we have talked about the two types of the methods wherein the properties are improved without changing the chemical composition, and just the structural modification is applied for improving the properties, and another category of the methods wherein the surface composition is modified for getting the desired set of the properties. And the third method, third category of the method where some kind of layer is deposited over the surface so that the required set of the properties can be modified. So what we can see: surfacing, coating, overlaying. These are the various names which are used for this purpose, depending upon the kind of process which is being applied for developing a layer of the suitable material. The approach wise, in this approach of the surface modification or improving the surface properties, basically the substrate whose properties need to be improved is kept in mind while selecting the suitable material. So, if it is corrosion resistance, hardness, wear resistance, which kind of property is to be improved, considering that requirement, the material having the required properties for improving the properties of the substrate is basically applied. So, basically in this case the coating or the surfacing or the overlaying of the suitable material is done. Suitable material is done which can really offer the required set of the properties. Maybe these may be in form of like adhesive wear resistance, cavitation resistance, improved hardness, improved corrosion resistance, improved the electrical properties. So, as per the requirement, suitable kind of the material is selected and then it is applied on the substrate surface. So, there are three broad categories of the approaches. One is called hot dipping, which is used for aluminizing, chromizing, galvanizing, chromizing, aluminizing. So, as per the kind of elements like aluminizing for aluminium, zinc for galvanizing, chromium for chromizing, the kind of the processes are used in this category. So, basically the liquid bath is used for this purpose. And then another category is the thermal spraying. Or we can say in this, and thereafter we have the surfacing. There are two category of the processes. One is weld surfacing and another is laser cladding. So, in all these methods, the layer of a material having the desired set of the properties is deposited or applied or developed on the surface of the substrate, and once this is developed, we will be machining it out so that required dimensional properties can be achieved in terms of the dimensions and the surface finish. There are basically three purposes of this kind of approach. One is which is used for the reclamation purpose. The second is like cladding purpose, and the third is the hard facing purpose. So, as per the kind of the function, the reclamation is one where, like say, the component after a long service has worn out, so it has lost its dimensions. So, what we do, the material is deposited on the worn out component so that additional material can be applied on the surface, and thereafter it is machined out in order to get the desired final size of the component as per the requirement. So, basically if the component was of this kind and after the service it has lost its dimensions up to this much magnitude. So, the additional material is deposited and then it is machined out so that original dimensions can be restored. This is what is called reclamation, where worn out components dimensions are and properties are restored. Cladding is basically used for depositing the thick layer of the corrosion resistant material so that it can really the substrate can really work for longer period under the corrosive environment conditions. And hard facing helps to increase the surface layer hardness for improved abrasion adhesion resistance, so that the rate of the material loss from the surface during the service can be reduced for improved life of the component. So, now these three approaches, these three category of the processes, now we will see the basic principles which are used in these three category of the processes. Like say in case of the hot dipping for galvanizing purpose, say if we see the kind of methods which are used, this is what we can see in this diagram here in this slide. Hot dipping is essentially a brazing process. Steel is cleaned mechanically and chemically and then heated up to above the temperature of 850 degree Fahrenheit in a molten zinc bath, and the molten zinc bath reacts with the surface of the steel and forms the coating over the surface, coating of various layers of the zinc and iron, depositing a layer of the material that is approximately 40% zinc. So, what is done here basically that the component, when it is dipped in the molten bath of the zinc after cleaning, so that it is free from all impurities, dust, dirt, oil, grease, etc., the zinc basically reacts with the surface of the steels and it forms the various compounds with the varying amount of the zinc and iron. So, at the surface it will have the higher concentration of the at the surface high zinc and less iron, and the zinc concentration will keep on decreasing with the increase of the depth from the surface. This is what we can see at the surface. It is eta zone where in the 100% zinc is present, then zeta zone where 94% of the zinc and 6% of the iron is present, then the delta zone where 90% of the zinc and 10% of the iron is present, and we can see there is a continuous increase in hardness from the 70 units to the 179 units to the 244 units, and then gamma zone is formed at the interface which is of the 250 units of the hardness, having much higher concentration of the zinc. So, much higher concentration of the iron, that is 75% zinc and 25% of the iron. So, here some kind of the metallurgical bond is created, and if we compare the galvanizing with the thermal spray coating processes, so we can see there is a clear interface and no such kind of the compounds are formed at the interface, although sometimes some of the elements get diffused into the substrate and some compounds are formed, but here it is more of the metallurgical bond, and here somewhat less metallurgical bond is created in case of the thermal spread coatings. Procedure wise, the galvanizing involves like the cleaning using the caustic solutions, and then it is rinsed properly so that the caustic solution is taken care of, and then pickling is done to remove any kind of the compounds, oxides, impurities, etc. if they are present. Then again rinsing is done, thereafter fluxing is applied, then molten zinc bath, the component is dipped into the molten zinc bath, and then it is subjected to the inspection. This is the kind of wet galvanizing approach. In any case, the proper cleaning using the mechanical and chemical methods helps to have the proper galvanizing of the components to be modified. So, this is what is there in where the zinc layer is applied using the hot dip galvanizing process. Primarily it is used for improved corrosion resistance. Another category of the process of the surfacing, coating and overlaying is that all these are of the one category wherein kind of a layer is built up over the surface over the surface of the base metal, so that the required properties can be achieved at the surface. Another category of the process is thermal spraying. Thermal spraying is the process wherein the material can be used in form of wires or the powders. So we have to choose in any case the material which is to be deposited for improvement in the properties. So that is the part of the design of the surface modification. So after choosing the suitable material in the suitable form, whether it can be in form of wires or the powders, these wires or the powders, the feedstock is fed into the heat source. So basically there is a heat source, and this heat source will be there in form of mostly flames. Flames moving at a different velocities with a different temperatures. So depending upon, there are various thermal spray processes like detonation gun spray, high velocity oxy-fuel spray, flame spray, cold spray. So the various processes with the different there is a plasma arc spray. So depending upon the kind of process of spraying, the flame temperature is different, and the velocity of the particles which is attained is also different. So what we do in most of these processes, conceptually they are same, that the heat source, this is the source of the heat in form of a arc or flame, and then in heat source we introduce the powder, which is a powder or the material to be deposited over the surface of substrate. So here when this material to be deposited is introduced, it gets heated. So heating leads to the two things. One is either softening, or it can lead to the melting completely, or it can lead to the partial melting. So depending upon the process, again the velocity achieved and the temperature attained, the different processes will be leading to the different conditions of the material which is being deposited, like either there may be complete melting, or there may be partial melting, or there may be just a softening. For example, in high velocity oxy-fuel process, high velocity HVF process, there is just the softening, no melting, but the melting takes place in the flame spray process, like the low velocity flame spray process. So in detonation gun and high velocity oxy-fuel processes, mainly the either partial melting or just a softening takes place. So these particles when they are added in with the heat source, they will be moving with the heat source. Depending upon the kind of heat source which is being used or suitable process being used, these particles will be heated, melted or partially melted, then they will be accelerated. And these particles in the soft state or in the partial molten state or molten state are accelerated, and when they so this acceleration just before the impinging or impacting the substrate on which coating is to be deposited, when the high velocity particles they hit the surface of the or impact with the surface of the substrate, they get flattened and gets deposited like this. So if it is in the molten state, after flattening it will get immediately solidified. This flattening leads to the formation of the splats. So a number of splats are formed one over other like this, and a layer of the coating is developed. Now there are various things like the temperature and the velocity are the very critical one, apart from the environment which is in which the coating is being carried out, because once the metal is there in the molten state, it will be interacting with the environment, and then it will be which will be affecting its cleanliness. Another thing, the temperature temperature will be determining the kind of the thermal degradation of the coating material which will be taking place in course of the spraying, and the velocity will determine how firmly it hits to the surface of the substrate and how firmly the bonding between the already deposited material or already deposited splats or the substrate is taking place. So, if the velocity is less, then some of the gaps may be left between the particles which have already been deposited, so which will be leading to the pores. And if a contamination due to the atmospheric gases is taking place, it will be leading to the formation of the inclusions. So, these are the common defects, and if the velocity is less, then the bond of the coating with the substrate will also not be good, because this bonding depends upon the mechanical interlocking and to some extent metallurgical bonding. So, these are the two main mechanisms which will be determining the kind of the bond between the coating and the substrate, and normally it is accepted that if the bond strength is of the 70 MPa, then the coating survives well under the normal circumstantial conditions. So, efforts are always made to have that the bond strength is at least 70 MPa, which is normally realized through the high velocity processes. So, the velocity plays a very critical role in determining the proper bonding of the coating with the substrate, otherwise it will lead to the delamination or the suppression or spalling during the surface, so which will be leading to the premature failure of the component due to the removal of the thermal spread coatings. Now, in this process, if we see, there is either melting or partial melting of the material which is being deposited, but there is no melting of the substrate. So, if that is the case, then the dilution is almost nil, there is no melting of the substrate, just the coatings get deposited over the surface of the substrate like this, and then splats over the splats get deposited one over other. Depending upon the speed, how firm bonding between the splats is taking place, that will depend upon the velocity. So, low velocity flame spray process, like say very low velocity is attained by the particles in course of the spraying, which is like say 50 to 100 meter per second. But if we talk of the higher velocity processes like the plasma arc spray, may be like say 200 to 400 meter per second, and the HVOF for high velocity oxyfuel process may be 800 to 1000 meter per second, and then detonation gun process offers further higher velocity like say 1000 to 1200 or even more. Then there is a cold spray process. So, as per the process, the peak temperature which is attained by the material in course of the heating and the velocity which is attained will be varying, and these two things will be determining up to what extent thermal degradation or the metallurgical degradation of the coating material which is being deposited is taking place, and the second is how firm bonding is taking place between the material, the coating material and the substrate. So, it becomes important to see the different kind of the processes and their comparative study. If we see, this is the process which is showing that the material is being deposited with the help of this spray process over the surface of the substrate. So, here the substrate is continuously rotated or the spray torch is moved as per the requirement, so that the suitable material is deposited over the surface of the component which is to be modified. This is another process, I will come to this one later. Here is this is the comparison of the different spray processes like flame spray, plasma spray and high velocity oxyfuel spray. So, in these all these processes, like powder is used as a feed material or the consumables for depositing the coating. Heat source in case of the flame spray, and also in case of HVF process is oxyfuel combustion, while in case of plasma spray it is the plasma arc which is used for depositing these coating. The maximum temperature which is attained in case of the flame spray is 3000 to 3500, 10,000 to 15,000 degree centigrade in case of plasma spray, and 3000 to 3500 in case of the HVF process. With respect to the particle velocity is very low, less than 300, 400 to 500 for plasma spray, and like say over 1500 to 2000. This is gas velocity. Particle velocities are very low. Particle temperatures attend like 1500 to 2000 degrees centigrade, 2200 degrees centigrade, 27 to 3500 degrees centigrade for plasma spray, and 15 to 2200 degrees centigrade in case of the HVA process. So the point is, if the material which is being deposited is heated less, then the thermal degradation and metallurgical degradation to the material which is being deposited will be less, and that is favorable. So it is always preferred that the particle temperature is less, but at the same time it should get softened enough so that it gets after impacting it forms the metallurgical bond and proper bonding with the substrate. Particle velocity determines the bonding to a great extent, and the particle velocity is very low for the flame spraying. It is 50 to 100 meter per second, while it is 100 to 200 for the plasma spray, and for HVF spray it is 1600 to 600 to 800 meter per second. So as per the processes, different processes will be leading to the different kind of the particle velocities and maximum temperature, and accordingly the cleanliness and the soundness of the coating will be determined. These coatings, when they are deposited, do not always perform well. These suffer some limitations also, and the common limitations of the thermal spread coatings include like the limited fracture toughness, limited toughness. Basically most of the time these coatings are hard and brittle, but these can be soft also. So the toughness, these coatings mostly suffer with the toughness. The thickness restrictions, like hard materials can be coated to the very low thickness levels, while the soft materials can be coated to a very thick level. For example, hard materials like alumina and like say titanium carbide, the coating thicknesses are say less than 200 micrometer, while the nickel, kind of the soft material, they can be deposited like say 3000 to the 5000 micrometer, means 3 to 5000 micrometer, any even more. So softer the material, greater will be the thickness, and harder the material, lesser will be the thickness which can be deposited. The bond strength is another limitation, because if the bonding of the coating with the substrate is not proper, then it will be leading to the delamination or suppression or spalling of the coating. So the purpose of the coating will be lost. So there has to be good bonding, and under the control conditions only the good bonding can be created, and there are many approaches which are used for improving the bond strength, but the bond strength is one of the limitations. Like high velocity oxyfuel spray and detonation gun spray process offer a good bond strength as compared to the low velocity flame spray processes. And application difficulties are like it cannot be applied in all kind of situations. It works in the factory environment, and since the velocities are too high with the high velocity processes like HVF and detonation gun process, so very rigid systems are needed for spraying purpose, so it cannot be applied in all the situations. Another one is another approach in the development of the coatings is the weld surfacing. So weld surfacing is basically uses the welding processes for depositing the layer of the coating. So here the substrate is say like this, and we can use any of the welding process which can be used for applying a layer of the suitable material. For example, it can be used sealed in metal arc welding process, TIG, tungsten iodide gas welding process, gas metal arc welding process, submerged arc welding process, or these are the process flux cored arc welding process. These can be used for depositing the surfacing. So in that case, what we use, the electrode having the desired kind of the alloying elements and constituents, and here we have welding arc. So when arc is there between the electrode having the suitable alloying elements, for developing a weld layer or weld bead, and so this electrode is used to strike the arc between the, in case of the say SMAW process, electrode is used to strike the arc with the base metal. So, heat generated melts the base metal as well as it melts the electrode tip also. So, the material gets transferred to the base, and this is how a bead is generated like this over the surface of the substrate. This kind of bead is called bead weld bead or bead on plate. So, basically it will be covering the substrate surface of the substrate to apply the layer of the material which is to be deposited. Depending upon the process, it offers the different heat input and the cleanliness of the weld. The weld surfacing deposited using the SMAW has less control over the heat input, and the cleanliness of the weld is also less. So, cleanliness is also less, and because of this we will have more amount of the inclusions and more dilution levels, because control over the heat input is limited. And because of these two aspects, basically what the dilution is, where this is the layer which is of the base metal which is melted, and then addition of this is the layer which is deposited. So, this thickness and this thickness, these are basically taken in consideration to see the extent of the dilution is taking place. So, the melting, the depth up to which melting is taking place is a depth dB, we can say the depth of the substrate or the base metal divided by the total depth of the weld surfacing. So, ds we can say. So, ds plus dB. So, dB, that is the depth of the base metal which has melted, divided by the depth up to which surfacing has been deposited over the base metal, and the depth of the base metal. So, basically this total depth is the weld surfacing, we can say dW also. So, in that case dB divided by dW, this is used for determining the dilution level. Dilution means the mixing of the base metal with the material which is being deposited. Greater is the melting of the base metal, greater will be the change in composition of the material which is being deposited. So, lesser will be the extent up to which purpose will be solved. So, efforts are always made in order to reduce the extent of the melting of the base metal, means efforts are made basically to reduce the extent of the dilution which will be taking place during the weld surfacing. So, with regard to this, basically laser cladding is found to be more useful, because it applies the more amount of heat and limited melting of the base metal. So, high energy density facilitates the melting of the coating material and limited melting of the base metal, leading to the lesser dilution as compared to the common welding processes. So, high dilution is encountered with the processes like the submerged arc welding process as compared to the like the GTAW, or because where filler is to be fed separately, because this process uses the non-consumable electrode. So, as per the kind of process we are using, the heat input and the cleanliness of the weld will be different in case of the weld surfacing. Submerged arc welding process is used when the very large area is to be deposited in the large quantity, while the GTAW gas tungsten arc welding process is used when high quality weld surfacing is to be done with the use of the less heat input. And for the general purpose the weld surfacing, basically sealed in metal arc welding process is carried out, while for a specific application at the industrial level, if the coatings are to be deposited, then industrial process like FCAW and the GMAW processes can be used, which basically in these processes consumable consumable electrode is used. So, consumable electrode can be used for depositing the coating material continuously in the larger quantity. So, in this process basically the electrode which is consumable and consumed in course of the deposition process. So, like in case of FCAW, what we do, suitable composition to be deposited is filled in the electrode, and then electrode is arc is struck between the electrode and workpiece. So, the melting of the base metal takes place as well as the melting of the electrode takes place. So, this is how it will be leading to the development of the weld bead deposition. Since it uses the consumable electrode which is fed continuously in form of wires, so the larger amounts can be deposited in one go over the larger area. So, this is more like a industrial process, both GMAW as well as FCAW. So, for most of the industrial applications where consistent quality is needed and a lot of metal is to be deposited over the larger areas, basically the gas metal arc welding and FCA processes are used for depositing the weld bead. So, different processes offer the different extent of the dilution and a different level of the cleanliness of the weld bead being deposited. Now, we will summarize this presentation. In this presentation, I have talked about the different methods related with the approach wherein a layer is deposited over the surface of the substrate for improvement in properties. Basically, I have talked about the three kind of the processes. One was the hot dipping, galvanizing, where in the zinc coating was deposited over the surface of the steels, and then another was the thermal spray processes, where the different thermal spray processes are there and they offer the different particle velocities and different particle temperatures which can be attained, and these two parameters govern the quality of the thermal spread coatings. And in the weld surfacing, there are various welding processes which can be used for developing the weld surfacing. So, depending upon the kind of heat input, control over the heat input, and the cleanliness of the weld is affected by the way by which the protection to the weld metal or the molten metal is given in connection with the each process. Thank you for your attention.